Okay, we're working on problem number 24 right now from section 13.1, and it says, give the greatest possible error for each of the following measurements. So if we have 23 meters, we can go either up or down. Now, when you take a measurement, it doesn't, it's hard to find a measurement exactly as to what it would be. So in part A, we're looking at meters. In part B, we're looking at centimeters. Part C, again, we're looking at meters. But you always can go either up or down by a half of whatever the precision it is. So on the 23, it could either go up to 23.5 or down to 22.5. So, and it's asking for the greatest possible error. So that one would be 23.5. Now on part B.
Wait, how do we know that? Like,
if you look back in 13.1, the error can always go up or down by a half of that next place value. So 23 is in the ones place. So to find the error, you either go up or down by half in the tenths place. On part B, it's 3.6. 6 is in the tenths place, so the error would be up or down by half in the hundredths place. So the maximum error there would be 3.65. And then the last one is 3.12. The 2 is in the hundredths place, so the error would be plus or minus a half of 1,000. So 3.125 would be the greatest possible error there. And this is explained on page 809 in section 3.1. Susan, in your edition, I'm not sure. You'll have to look carefully in you're in chapter 14, right, Susan?
yes.
Okay, let me just read it to you. When drawings are given, we assume that the listed measurements are accurate. When actually measuring real-world objects, such accuracy is usually impossible. Measuring distances in the real world frequently results in errors. Thus, many industries rely on portable calibration units to test measuring instruments used in constructing parts. Calibration helps ensure that all parts fit together. To calibrate measuring instruments, industrial technicians establish the greatest possible error allowable in order to obtain the final fit. The greatest possible error of a measurement is 1/2 the unit used. So in part A, the unit used was to the nearest 1. So to get the greatest possible error, we can go up or down by 0.5. So the larger being 23.5. For part B, we have 3.6. So you can do plus or minus 0.05 because 6 is in the 10th place. The 3.65 would be the high end on that. And then part C, we've got 3.12. And we do plus or minus 0.005 on this one because the hundredths place is what our number is at. So you have to go out to the thousand.
Wait, why does it change? Because its meters just like C is the same unit as A.
But
And if
A
A,
is only measured to the nearest whole number. Whereas C is measured to the nearest hundred. But still meters on all. Well, A and C are meters. B is centimeters. But it's talking
but
about place
I-
value.
because I would just think it would be the same. It could be like, 2.6 or 3.6. I just don't understand why you
In
move
part
the
B?
decimal. No, in C. I didn't like, so you're saying the place value is what dictates where your error would fall versus what the
Yeah.
unit of measure is.
Right, so you're looking at the 3.12, since you were given a measurement to the nearest hundred. To get your greatest possible error, you're gonna add half of the next place value, which is thousandths. So you're gonna add half of a thousand. So 0.005. So the error falls within plus or minus 0.005. The greatest would be the higher one, so 3.125. The plus or minus, I said it wrong. The plus or minus gives you the range. To get the greatest, you take the plus. You're adding half of that next place value. Half of the unit. So half of 100 would be a 5 in the thousandths place. Half of a tenth would be a 5 in the hundredths place. Half of a whole number would be a 5 in the tenths place.
So really the unit of measure does not play into part here.
No, it doesn't.
They were just trying to trick us.
I think I just need to chunk this video because the wording I used at first wasn't right. The greatest possible.
I'm okay with you chunking it.
Unit. So the range is plus or minus, but the greatest one is if you just add half of the unit. So half of 1 is 0.5. Here we would have to add half of a 10, making it 3.65. In other words, 500. And here you'd have to put on half of 100, making it 3.1.
So in the book, they're using, so we do need to carry over the unit of measure, but it also says, interesting enough, on the C part, it's either 0.005 meters or 5 millimeters.
Yeah, I mean, that's just another name.
Yeah.
0.005 meters is the same thing as 5 meters. And so the way that this is useful in the real world is I think of my, my uncle that worked for Caterpillar up in Pontiac, Illinois for many years, and he was in the quality control department. And when they made their parts, they had to fall within a certain range, otherwise they had to be thrown out and couldn't be used in the engine.
I can see that. Okay.
Like if it's within this range, okay, acceptable, we'll keep it. If it's outside of that, it's too far off.
I know we don't have much time, but somebody in the chat's wanting to see 13.2 number 25, and they're not home, so they can't get on.
Okay,
Can you stop putting that on my house?
What number was that?
I think they said 13.2, all right, 13.2 number 25. Hold on, let me see. Yeah, she's saying number 25 in the assignment, 13-2A.